So this next section, we're going to be talking about permutations and combinations. So I'm kind of jumping around the notes here. You have to put the permutation and combination is a little bit down on the first page. So a permutation is an arrangement of items where order matters. And it's really important here that you remember that permutation goes with order matters, because in a combination, the order does not matter, or it's not important. So you need to make sure that you differ somehow on your notes there, that permutation order matters, combination order does not matter. So when we're doing our problems, we're going to have to differentiate between the two. And then here we have our formula. So for permutation, you have this formula here in the box, which is n factorial over n minus r factorial. And we learned how to solve the factorials yesterday. So n is your total, and R is your arrangement. So how many things they want you to arrange. And that goes for both the permutation and combination. And so this up here is the permutation formula. And then your combination formula is very similar. The only difference is it's n factorial over r factorial times n minus r factorial. And again, you'll see how this plays out in the problems as we're doing them. So just make sure you have permutation order matters with its formula, and then combination that order does not matter with its formula written down. So for example, our first one here, the environmental club is electing a president, vice president, and treasurer. How many different ways can the officers be drawn from 10 members? So n again is our total, so we have 10 total members. And then I have to figure out what R is. So R is the arrangement. So I have a president, a vice president, and a treasurer. That's 3 different people. Now, to figure out if this is a permutation or combination, remember permutation order matters, combination order doesn't. Now, when you're choosing someone for president, vice president, or treasurer, that's basically like saying first, second, or third place. So order definitely does matter here. So that's going to be permutation. And so remember, our permutation formula is n factorial over n minus r factorial. And you won't have to memorize those. You'll be given them on the test. But for the problem, so now we're going to put n is 10 and 3 is r, and I'm going to plug in from there. So I have 10 factorial over 10 minus 3 factorial. And you can write this all out if you want. We'll take a look at what it looks like when it's all written down. So 10 factorial, remember, it's 10 all the way down to 1 with multiplying. And then over. Now 10 minus 3, this simplifies down to 7 factorial. So I'm going to do 7 times 6 times 5 times 4 times 3 times 2 times 1. Now if we look here, some things are going to cancel out because 1 divided by 1 is 1, 2 divided by 2 is 2, so on and so forth. So everything cancels out up to 7, and what I'm left with is 10 times 9 times 8 on the top. So I'm going to do 10 times 9 times 8, and that's going to give me 720 ways to pick the president, vice president, and treasurer. So you get your numbers from, first you have to choose if it's order matters or doesn't matter. Then you plug in your numbers, and then you just simply solve and cross out what cancels out. So our next example, we have 12 swimmers compete in a race. And how many possible ways can the swimmers finish first, second, and third? So again, n is our total, so we have 12 total swimmers. Then I got first, second, and third, so I have 3 places. Again, order definitely does matter here because it matters who gets first place and who gets third place. There's a big difference in those. So we're doing a permutation. So I'm going to do 12 factorial over 12 minus 3 factorial. And again, I'm plugging this into the permutation formula, which you should have written down. Now, if we simplify here, I'm going to do 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And some of you won't have to do this because you guys can see what's going to cancel out. Because if we look, if we do 9 factorial, everything underneath 9 is going to cancel out. So all this goes away. And I'm just left with 12 times 11 times 10, which equals 1,320 different ways that people can get first, second, and third. Our next problem says, suppose that you choose 4 books to read on summer vacation from a reading list of 12 books. How many different combinations are there that you can read the books? So our total number of books is 12. That's how many books we have total. And they're trying to read 4 books on summer vacation. It doesn't say that it matters that they have to read a certain book first. It doesn't matter. All that matters is that they read 4. It doesn't matter what for. So this makes us a combination. So remember, our combination formula is n factorial over r factorial times n minus r factorial. So my n is 12, my r is 4, and I'm going to just plug in from here. So I'm going to do 12 factorial over 4 factorial times 12 minus 4 factorial. And if we write this all out, we get 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. Now I'm going to do 4 factorial first. So I'm going to do 4 times 3 times 2 times 1 times 12 minus 4 factorial, which is 8 factorial. So then I'm going to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So now last time we did the permutations, everything canceled out. When we do combinations, not everything's going to cancel out because we have the extra r here. So what's going to cancel out is I'm going to have everything. 6 and 9 will cancel out. My 7 will cancel out. My 8 will cancel out. So I'm left with, so you can see this better, I'm left with 12 times 11 times 9 on top over 4 times 3 times 2 times 1 on the bottom. And so that gives me 11,880 on top divided by 24. And if we simplify that, you get 495 different ways. So combination is a little bit more confusing. You definitely want to make sure you write your answers out for that one. And so we'll do one more combination example. We have 8 freshmen and they pick 5 to be on the cleanup crew. Again, it doesn't matter who is on the cleanup crew or because they're not doing something specific, so the order doesn't matter. So this is a combination. So you have 8 combination 5. So we're going to do 8 factorial over 5 factorial times 8 minus 5 factorial. So if we write this all out, we get 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, start with your 5 factorial, 5 times 4 times 3 times 2 times 1. Then simplify here. 8 minus 5 is 3 factorial. So I'm going to go from the 1. I'm going to do 3 times 2 times 1. Now if I cancel things out, cancel, cancel, my 4's cancel, and my 5's cancel. So if we look here, what I'm left with 8, 7, and 6 on the top, and I'm left with 3, 2, and 1 on the bottom. So you get 8 times 7 times 6 over 3 times 2 times 1, which gives you 336 over 6, which simplifies down to 56 different ways to choose the crew members.